Hello there, Mr. Sutton here, bringing you the IM3 Chapter 7 Quiz 3 review solutions on advanced triangle trigonometry.
On this problem, I'm trying to find the area of this triangle that I have no idea if it's a right triangle or not, probably isn't, but we have the angle and the two legs of the angle, side, angle, side. So if you're finding area in this situation, you need to use the half-sine formula. That's k equals 1/2 AB sine c. So that's going to be 1/2 times one of the legs times the other leg. So we'll say 3 times 8. Still have that 1/2 out there. And then we have to multiply by the sine of the angle between them, so sine of 60. And let's just do all that out on the calculator. So on my calculator, it got cut off a little bit there, but I'm doing 0.5 times all this stuff, just so I don't get anything in weird fractional mode. And pressing enter, that's going to be 10.4. On this problem, trying to find the area of a triangle where I have all three sides. So in this situation, I need to use Heron's formula. So there's two parts to this. The first part, we have to find S, the semi-perimeter, which is what it sounds like. You're basically taking half of the perimeter, half of all the sides added together. So that's 1/2 of 13 plus 20 plus 17 in whatever order you want. Let's just do that on the calculator real quick. So half of all that stuff added together comes out to exactly 25, which is a nice number. Now to actually get the area, we need to use the k part of this formula. K equals the square root of, and then we're going to have s times s minus a times s minus b times s minus c. Basically, semi-perimeter subtracting all of those things. So now's the time to plug all of that in. We've got that big square root. And s, remember, we just found was 25, so we have 25 for that first s. And then 25 minus whichever one of these you want to start with. Let's just use 13. And then 25 minus 20, and 25 minus 17. And I'm just going to plug all this into the calculator all at once. I'm not going to bother simplifying first. So plugging all that in under one big square root, pressing enter, we end up with approximately 109.5. On this problem, we're trying to find the side of a triangle that we don't know for sure is a right triangle. In fact, looking at the angles that we have, it definitely isn't. There's more than 90 degrees left over after you've used these up. So in this situation where you can't use SOHCAHTOA and you have an angle and a side across from each other that you actually know, we're going to use something called the law of sines. So that's sine of A over A equals sine of B over B. And I'll start with the side angle pair that I actually know something about. So I can say sine of 30 over 9 equals sine of the other angle, 45 degrees, over the side across from it, which is the x that we're looking for. Now I just have to solve for x, which I'm going to have to do by cross multiplying. So I've got 9 times sine of 45, and then I would have x times sine of 30, only I'm immediately going to divide by sine of 30, and it ends up down here in the denominator. So let me just plug all this in the calculator at once. So to make this a little easier to look at, I'm just going to do alpha y equals, and then n over d, my fancy fraction mode. So I've got 9 times the sine of 45, and then I'll go down here and do sine of 30, press enter, and that comes out to about 12.7. Now, since we're finding a side with the law of sines rather than an angle, there's only one answer for this. We don't have to find any alternate answers. For this problem, trying to find an angle in a non-right triangle, definitely a non-right one because 130 doesn't leave any room for a right angle. So in this situation, if I have the angle and a side that's across from it, I can actually use the law of sines for this. So sine of A over A equals sine of B over B. So let's start with the angle side pair that we know the most about. We have sine of 130 degrees over the side across from that, so 15, equals sine of x, because that's the angle we want, over the side across from that, which was 11. So to get x by itself, I first have to get sine of x by itself. So let's multiply both sides by 11. So that gives me 11 sine of 130 over 15. And now to get x, I have to take the inverse sine of all this stuff, which I will now do on the calculator. So here we go on the calculator. Let me do second sine to get sine inverse. And then I'll do alpha trace, or actually alpha y equals n over d fancy fraction, and now let me do 11 sine of 130 up there. And then let's go down below, and we've got just 15. And we can close that whole parentheses if we want, although there's nothing after, so it's not needed. Press enter, and that comes out to about 34.2. So that's awesome, but it's not the end of the problem. When you find an angle with law of sines, just the way things are set up, there's always the possibility that you might have also the supplementary angle as an answer. So to figure out the other possible answer, we have to subtract this from 180. So let me just do that on the calculator. I've already got it out. So 180 minus 34.2. And so our other possible answer is 145.8. Now, before we can just go ahead and say, hey, this is my other answer, we have to make sure that this is actually going to fit in the triangle with the angle that's already in there. So if I do 130 plus 145.8, is that going to fit in a triangle? Well, since you only have 180 degrees to spend in your triangle, this adds up to something over 200. So this is definitely well over 180, which means that our alternate answer is actually no answer at all. It doesn't really make a triangle that could ever exist. So the only answer then is this 34.2. Now, in terms of getting credit on a test, you need to show that you have considered this alternate angle and then give a reason for crossing it off. You can't just write 34.2 with none of this other stuff and get full credit. You have to show that you actually got this because you know what you're doing. On this problem, I'm trying to find a missing angle with a non-right triangle. So since I have an angle and a side that are across from each other, this 35 degrees and this 89, let me try the law of sines on this. So sine of A over A equals sine of B over B. So let me start with just the pair that I know. Sine of 35 over 89 equals, and now we have just sine of X over 102. Let's get sine by itself first. So 102 times sine of 35 over 89. And then let me take the inverse sine of both sides to get the actual angle out of this. So I entered a bunch of stuff off camera. I did second sine to get sine inverse. I did alpha y equals to get my fancy fraction mode. Plugging all that in, we get 41.1, and that's degrees. But now we have to check for the alternate answer, because whenever you do law of sines with angles, there's a possibility that the supplementary angle would also be an answer. So if we do 180 minus 41.1, let's see what that comes out to on the calculator. So just subtract. I could probably do it without one, but just to be on the safe side, 138.9. Now, is that a legitimate answer? Well, does it fit in the triangle with the angle that's already there, this 35 degrees? If I add those two angles together, the 138.9 and the 35, I can tell, since that's going to be like 170 something, that's definitely going to be less than 180. I don't have to say exactly what it is, but it's less than 180 for sure. So that means that both of these answers, 41.1 and 138.9, are valid, correct answers for this problem. For this problem, we're trying to find a missing side. It's not a right triangle, at least as far as we know, but we do have information about a side angle side set over here. So when we have side angle side, we can use the law of cosines. That's c squared equals a squared plus b squared minus 2ab cosine of c. So this is actually one version of the law of cosines, the one that helps us find third sides. So for this one, we have c squared, that's really x squared in this case. And then a and b, those are the legs of the angle that they gave us. So we can write 3.8 squared plus 7.5 squared. And then we have a and b getting used again, so minus 2 times 3.8 times 7.5 times the cosine of the angle they gave us, the cosine of 50. So I'm going to simplify everything on this right side on my calculator. So let me just enter it all in there. We have 3.8 squared plus 7.5 squared. And now we're going to be subtracting. We have 2 times 3.8 times 7.5. So lots of stuff to enter in here. Times the cosine of 50. And close the parentheses if you want. Press enter. It's about 34.1 if we round that off. Now keep in mind that that's just x squared that equals about 34.1-ish. In order to get the true value here of x, we have to square root both sides. So let me go back to my calculator, and let me do second for square root there. And then a little trick I'm going to use the actual value that we just got. So let me arrow up and grab that input by pressing enter, and then press enter again, and that ends up giving us 5.8 for that missing side. On this problem, we have all three sides, side, 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 and we're looking for an angle. Since we don't know whether or not this is a right triangle, to be on the safe side, we'll use the law of cosines. Now, the version of the law of cosines that helps with angles is cosine of c equals a squared plus b squared minus c squared all over 2ab. So for this one, we have cosine of x, and then we have a big fraction. And now let's pick out the c value. Now this is always going to be, in these problems with law of cosines, c is always the side that's across from the angle you're trying to find. In this case, we're trying to find this angle in the lower left, so that means our c value is this 6 over here. And then a and b are going to be the 10 and the 7, or 7 and 10. Doesn't really matter which is which for a and b. So I'm going to write 10 squared plus 7 squared up here, minus, now this one's really important, minus 6 squared, all over 2 times 10 times 7. And now let me plug this in my calculator. So I'm going to start by simplifying the right side of all this stuff. So let me just do alpha y equals to get my fancy fraction, press enter on n over d. And then we've got 10 squared plus 7 squared minus 6 squared all over, and now we have 2 times 10 times 7. And if I just press enter now, it'll simplify that fraction for me. So that's 113 over 140. And I'll just write down here that cosine of x equals that. But now, in order to get x, I need to actually take the inverse cosine of what I just came up with. So let me do second cosine for cosine inverse. And then let me just cut and paste this by arrowing up and pressing enter. And then I'll close the parentheses, press enter to actually get the inverse cosine. That's going to be 36.2 degrees. And the nice thing about law of cosines, unlike law of sines, when you find an angle with law of cosines, there's no alternate answer. It is just this one answer.